Hello, hello, hello. Good morning, good morning, good morning. It is a good morning. Well, today I want to show you something which demonstrates how, with a little bit of math and a little bit of science and just a little bit of logic, we can do something that seems impossible. Like the air. You don't feel it pushing down on you, but it does have weight. How much does it weigh? How do we put it on a scale? Well, it's very hard to put the air on a scale, but we do know air pressure, and we're going to use that. So let's think about our atmosphere. We have the Earth here, right? And the Earth has this razor-thin layer of atmosphere. I mean, this is really exaggerating just how thick it is. It is incredibly thick. If the Earth was the size of a baseball, the laces would be sticking up into space. That's how thin the atmosphere is. If the Earth was the size of a basketball, the little tiny dimples in a basketball would be high enough where if you were standing on one of those little dimples, you probably would pass out because the air would be so thin. And there's all sorts of things that you got to worry about because, okay, what's the density here? It gets thinner out as you go out. How do you calculate the mass of air? Well, you could try to figure out the density going from 101 kilopascals all the way out to 0 kilopascals at an infinite distance out, and then try to do that. Or you could just do something very simple. It's all coming down on us. It's all pulling down on us. Let's just take a simple formula. So here's a formula. Pressure. Is that black? Pressure is equal to force over area. Now I'm going to change this because I'm going to multiply both sides by area. So that cancels out, and we get force is equal to pressure times the area. Force is equal to, now pressure is 101 kilopascals. That's 101,000 PA. But I'm not going to actually put it this way. I'm going to put it in scientific notation, so that means, and you'll see why. It's easier to do it. Just do it in scientific notation. A lot of people are intimidated by scientific notation. The reason we use it is once you get used to it, it is a lot easier. So I moved the decimal point 1, 2, 3, 4, 5 places. So it's 101, 1.01 times 10 to the 5th pascals, okay? Now, times the area. What is the area? Ooh, tricky question. Well, you may remember from geometry class, or maybe you don't, that if you've got a sphere, the formula for the area of a sphere is 4 pi r squared, because if we're trying to find, the weight, the force of gravity of it, it's the pressure, and where's the pressure pushing? All over the entire surface of the Earth. So if we find the area of the surface of the Earth, we got the area, we already know the pressure. So 4 pi r squared is our formula. 4 pi r squared. Let's keep going here, shall we? So, now I am holding the brown marker. Okay. It's the same, doesn't it? Okay, so, anybody notice any difference between the black marker and the brown marker? They both look brown, don't they? Isn't that weird? Maybe I just got lucky. Okay, F is equal to 1.01 times 10 to the power of 5. That's the pressure. By the way, I won't write our units in every time, but I will for a little while. Times 4 pi. What is r squared? What's the radius of the Earth? Well, we don't need to go back to Ptolemaic Egypt to find that out. Although maybe I'll do a video on that someday, but I'm not doing that video now, okay? No, I'm not. All right, so we will just go with the number that we use that's generally accepted, 6,371 kilometers. We're not going to leave this in kilometers. And part of it is units. Pressure is newtons per meter, or per meter squared, right? So pressure, a pascal is a Newton per meter squared. But a lot of people get screwed up with the kilometers because it's squared. That's key. Everybody says, oh, a kilometer is 1,000 meters. That's true. What tends to get people caught up is they say, okay, a square kilometer is 1,000 square meters. No, it's not. A square kilometer is 1,000,000 square meters because it's 1,000 by 1,000. It's 1,000 times 1,000 is 1,000,000. So in order to avoid that possible screw up, we're going to put everything into meters here. So 6,371 becomes 6.31 times 10. Okay, times 10 to the 6 because we moved the decimal point over 3. That was for kilometers. Give it another 3, going kilometers to meters. And remember, the whole thing is squared, okay? Don't forget that squared. I am always losing square roots. And they're important. They are incredibly important. All right, so let us keep moving here. Now, just going to do a little math here. Moving, standard math. F equals 1.01 times 10 to the 5th newtons meters squared times 4 pi. What is 4 pi? 4 pi is 12.566. Yes, it is. Okay. Now, squared. 6.371 squared is 40.5. 0.59. 10 to the 6 squared, just multiply 6 times 2 is 10 to the 12th. Now, by the way, we're no longer in scientific notation. You can put it back in scientific notation, or you can just wait till the end, all right? So, continuing along here. And by the way, meters, this was meters, right? If we square that, these become meters squared. Our units also square. And let's just cancel meters squared, we're left with newtons here. Multiply it all together. F equals, I just multiplied it. I already did this ahead of time. I'm really writing things down. 516.8. That's 1.01 times 12.56 times 40.79 or 40.59. You multiply all those together, you get 516.8 times. Scientific notation is so easy. 10 to the 5th times 10 to the 12th. You just add 5 and 12, so it's 10 to the 17th newtons. That's the only unit left. Okay? Now, got to put in scientific notation. 1, 2 decimal points, right? So force is equal to 5.16 times, well, this got 2 places smaller, this has got to get 2 places bigger in order for it all to be the same. 10 to the 19th newtons, which is pretty freaking heavy when you think about it. Now, that's not the mass. Most people don't, how many newtons do you weigh? I'll bet you don't even know. Most people think in terms of mass. And so, if you want to think about that, your weight is the force of gravity, and that is equal to your mass times 9.8 Earthlings. If you're on another planet, you need a different number here. However, if you're on another planet, this also needs to be different, that needs to be different, everything needs to be different, but you can get the idea. Apply this to whatever planet you live on, okay? All right, so let's find m. So in order to do that, divide both sides by 9.8, and you get mass is equal to the force of gravity over 9.8. So let's just do that. Mass is equal to, the force of gravity was 5.16 times 10 to the 19th newtons over 9.8. And what you get is, what do you get? So anyway, that's the weight. And what I get is 5.3 times, well, I get 5.27 times 10 to the 18th. Kilograms. Just a little word here. We have 3 sig figs. We only have 2 sig figs here. So we're going to have to round this to 2 sig figs. M is equal to 5.3 times 10 to the 18th kilograms. And that is the mass of all the air. You can look it up on Google. You're going to find a number which is pretty much just like this. I hope. Otherwise, I've really screwed up. Anyway, I just wanted to give this as a demonstration of how, with a little knowledge of science and a little bit of math, there's really nothing you can't solve. But anyway, I hope you've enjoyed the video, and I'm going to try to get more up soon. I'll see you later. Bye-bye.